I'm going to go through hand dosing chlorine, including how to calculate how much to use, choice of substance, and dosing methods also. So the first step in this is to calculate the volume of your swimming pool that you're going to be manually dosing. So for example, say you had a pool that is 20 meters by 10 meters and it had an average depth of 1.5 meters. If you multiply all those figures together, you'll get a overall volume of 300 cubic meters of water in the pool. Now, the next part of this is to calculate how much chlorine you would have to input into that volume of water to increase the free chlorine, let's say by 1 milligram per litre. It's easier if you work in multiples of 1. So if we, in this hypothetical situation here, this obviously you have to replace all of these measurements with the measurement of your own pool, but if we wanted to increase this pool's free chlorine level by 1 milligram per litre, well, what we're trying to do is basically put 1 gram of chlorine into every one of those cubes, because 1 milligram per litre, which is what you measure your free chlorine in, is equal to 1 gram per cubic meter. That's how the metric system works. So what we're saying then, we want to increase by 1 milligram per litre, which is the same as saying we want to increase by 1 gram per cubic meter. We've got 300 cubic meters, therefore we need to introduce 300 grams of chlorine into this swimming pool water. Okay, so we know how much chlorine we want to add into the swimming pool, but the next thing we've got to do is look at the chlorine donor that we're using, because neither of the main ones, calcium hypochlorite there at the top and sodium hypochlorite at the bottom, neither of them are 100% chlorine, far from it. So adding 300 grams of calcium hypochlorite is not going to give us 300 grams of chlorine. Adding 300 milliliters of sodium hypochlorite is not going to give us the 300 milligrams per litre of chlorine. So we've got to look at the percentage strength of the product that we're going to be actually hand dosing with. So calcium hypochlorite generally is about 65% strength, but you would need to double check that, because there are some products on the market that are stronger, some weaker, but generally tends to be about 65%. Sodium hypochlorite is fairly weaker. It varies, but somewhere between 10 to 15% strength for sodium hypochlorite. So to calculate how much, depending on which substance you're using, to calculate how much to put in, what you need to do is take 300, because that's how many milligrams per litre that we want, that's how much chlorine we want, but we've got to divide it by 0.65. And in the case of the sodium hypochlorite, let's say we were using a product that's 15% strength, then we would need to take the 300 and divide this time by 0.15. So what we would end up with, we would need, once you've done these calculations, it works out as 462 grams for the calcium hypochlorite and 2000 milliliters for the sodium hypochlorite. So we're having to add more of the product to make up for the fact that it's not going to be, neither of them are 100% chlorine. And so the next thing to think about is how to measure out safely this required quantity. Now, in terms of manually handling these chemicals, sometimes the liquid products can be more problematic than the solid products, but then again, the calcium hypochlorite, when you're handling that, especially if it's granules, it does kick up a lot of dust. So with both of these chemicals, obviously you're going to be wearing the appropriate PPE, but because of the different properties, some hazards will be present with the calcium hypochlorite, and some hazards will be present with sodium hypochlorite. Whatever you do, though, you've got to risk assess, every step of the way. So, for example, with the sodium hypochlorite, it usually comes in these sort of 20 kilogram sort of barrels. Don't attempt to pick that up and somehow pour out the required quantity. That's just asking for trouble. That is not going to work. Find a way, if you're going to use this particular substance, of getting it into the decanting it out accurately but safely as well. Maybe use something like this, which is a purpose designed pump for transferring chemicals from one container into the other. And then if you're using the calcium hypochlorite, again, have procedures in place that have already been thought through, so that they're ready to be utilized when you need to. And what might be a good idea is to get a set of digital kitchen scales and some sort of jug, some sort of receptacle where you can measure out the exact quantity that you need. So in this case, I've gone with the example of calcium hypochlorite. So we've got on the scale 462, measure out 462 grams in there, and then either mark it with a marker pen, or you could even maybe cut the jug down to size, so a level scoop will be equal to 462, and store it by the calcium hypochlorite. Label it up as well so that everyone knows what it is, that it's only for hand dosing purposes, and it's not to be used with any other chemical, because there's going to be health and safety implications, obviously, when you don't want to be mixing chemicals together. So once you've created a jug like this, it becomes very easy then, because if you wanted to increase the free chlorine in your swimming pool by just 1 milligram per litre, well, once you've created this this jug, then you know that's all you're going to need is just one jug to get the chlorine up by 1 milligram per litre. Of course, you could just multiply up then. So if you wanted to increase the free chlorine by 3 milligrams per litre from where you're currently at, then just you know it's just going to be 3 jugfuls. Because what you don't really want to be doing is having to get out the digital kitchen scales and do all these measurements and calculations every time. You want to get a procedure prepared in advance that takes into account all of the measurements and calculations and health and safety implications, and it's all been thought through in advance. And so when the time, if the time comes that you ever do need to hand dose in this way, you're good to go. You've got a procedure that you know is going to work. So the next thing to think about then is how to get the product into the pool safely. So we've done all the calculations, we've done the volume, and we've worked out how much quantity of substance we need. The next step is to actually introduce it to dose it into the system safely. Now there's options here. There's more than one option available to you, and again, what you've got to do as part of the risk assessment process is to evaluate the hazards and the risks with all of these methods and choose the most appropriate one based on your circumstances and your situation. So I'll run through some of the options. One of them is to introduce the chemical into the pre-pump strainer basket in the plant room. Pros and cons with this. It's a good option in terms of there's a filter in the path of this component and the pool itself. The good thing I think about that is the fact that the filter is going to be acting as a protective measure, so that there's no possibility of any sort of undissolved. If we're thinking about calcium hypochlorite, you're not going to be getting undissolved calcium hypochlorite able to get into the swimming pool, because it's had to go through the filter before it gets to the swimming pool. And I think as well, the filter itself would probably benefit from sort of being hit by a locally concentrated amount of chlorine. So you sort of superchlorinating your filter. But that's not the only option. There are other options. For example, if you've got a deck level pool, you can introduce it into the balance tank potentially. So for example, what you've got here is this is the balance tank access lid. Those are usually pretty difficult to get up, but you don't need to, because what you can do is just lift a section of this transfer channel cover. Just lift it up and you'll see how the water drains from this transfer channel down into the balance tank, and you can just introduce the substance there, and it will when you place it carefully into the transfer channel, the overspill from the bathers will take the product into the balance tank, and from the balance tank then it will be drawn through the rest of the system. A disadvantage here is the fact that you are bringing chemicals, dangerous chemicals, into the pool environment itself, where potentially members of the public, for example, or even children could, if things aren't done carefully, come into contact with those chemicals. Another option is to introduce it into the skimmer baskets. So you would lift up the cover to the skimmer baskets and carefully place the product into the skimmer basket. Again, it's got some of the disadvantages that I mentioned with the introducing it into the transfer channel to the balance tank. Yet another option is to introduce it directly into the pool, but what you absolutely must make sure of is that if it's, for example, calcium hypochlorite that you're using, you've got to make sure it's fully dissolved before you introduce it into the pool. The last thing you want, obviously, is somebody to come into contact with undissolved product. So to ensure that, you'd have to mix it into a solution first. So you'd start out with the water first and then add the product to the water, never the other way round. Mix it into a solution and then broadcast that solution over the surface of the swimming pool, sort of spreading it as far and wide as you can. Maybe transfer it from the mixing container into something like an ordinary garden watering can, so you can distribute the chemical as much as possible over the surface area. And you'll need to allow time for the chemical to mix in with the pool water and reach all areas of the pool so that there are no sort of dead spots. How long that's going to take is difficult to predict. So what you have to do is verify through testing with the DPD1 tablet. Yeah, there are pluses and minuses to all of these options. And it's a case of doing a thorough risk assessment to select the most appropriate option for your situation, really. So at this point, it's worth looking at a case study here that involved a chemical incident at a swimming pool. Essex Swimming School fined for chemical burns to a 3-year-old girl. Let's have a look at the details here. A 3-year-old girl suffered first-degree burns after sitting in corrosive cleaning fluid at a swimming lesson, a court heard. The chemicals were spilt by maintenance staff at a teaching pool run by First Stroke Swim Schools in Stanway near Colchester. The company admitted 3 breaches of the Health and Safety at Work Act at Chelmsford Magistrates Court. A district judge fined the firm £10,500 and ordered it to pay £2,350 in costs. The girl was sitting at the edge of the pool waiting for her lesson to start when she began to complain of pain in her leg, the court was told. When her mother took her to Colchester General Hospital, doctors said she had suffered first and second degree burns. First Strokes admitted a contractor had undertaken maintenance work earlier in the day using the company's own supply of sodium hypochlorite to treat the pool water. A small amount of the chemical spilt onto the side of the pool, the court heard. Prosecutors said that the company had failed to assess the pool water treatment and cleaning chemicals used at the site and failed to supervise the contractors properly. The company also admitted it had failed to comply with 2 improvement notices for its lack of hazardous substance control assessments and to not having a safety system for dosing the pool by hand. Mike Lilly, a councillor at Colchester Borough Council who brought the case, said the public should be reassured that we take a very dim view of any business that fails to put health and safety first and whose actions lead to personal injury. So I thought I'd include that case study there just to reiterate to you that there are dangers obviously involved with the hand dosing of chemicals. It shouldn't be the norm in any commercial swimming pool environment, but it is something that pools may need to do once in a blue moon for for keeping a pool open, for example, while the automatic dosing system is malfunctioning or something like that, maybe the safer option though to simply close the pool while the necessary repairs to the automatic dosing system are carried out. So this isn't a task that should be taken on lightly. It definitely isn't a task that somebody who is inexperienced in pool water treatment should be attempting. But I hope you found this this information useful in helping you to devise a safe way of hand dosing a swimming pool.